All right, guys, it's time to put it all together. At this point, the things that you have got to have burned into your brain is that sine of theta, or sine of any angle, is opposite over hypotenuse. That's where we get the little acronym SO. You should know that the cosine of any angle is adjacent over hypotenuse. And that's where we get the acronym CA. Excuse me. And we know that tangent of any angle should be equal to opposite over adjacent, and that's where we get the acronym TOA. SOHCAHTOA. Well, now what we're going to do is we're going to put this together and try to actually figure some things out. See, we haven't been using this to its full extent. One of the things I love about math is that everything you can do, you can undo, okay? And so there's something back when we were studying functions and we had f of x is equal to, say, x squared plus 3. If that's the function f, it's possible to find out what the inverse function is, okay? And so how you would do that, and this is a more of an algebra lesson than what we're going to do right now, is you would start with this idea that y is equal to x squared plus 3. You swap the x and the y in place of each other, and then now what you do is you solve for that y, okay? And so at this point you would go, well, I will say I'm going to subtract 3 from both sides. I get x minus 3 is equal to y squared, and so therefore y is equal to plus or minus square root of x minus 3. And so then the inverse function of f is this right here. And so how you denote the inverse function is you use this little -1 exponent, and so you'd say the inverse function of f is equal to plus or minus square root of x minus 3. And so these functions are inverses of each other. Whatever this one does, this one undoes. And I can prove that by if I take this right here and actually put it inside this function. Watch, I say f of square root of x minus 3 is equal to square root of, let's get that, do better than that. Square root of x minus 3 squared plus 3. And what does that equal? Well, these obviously take care of each other. So you get x minus 3 plus 3. So you just get x. See? So these functions are inverses of each other. Whatever one does, the other one undoes. Well, these same kind of things exist for trig functions. Okay? Now, when we talk about trig functions, we said the input of every trig function, and hopefully I've hammered this enough, the input of every trig function is the measure of an angle. The output of every trig function is the ratio of two sides of a right triangle, okay? And so we can undo that. And I'm going to show you exactly what I'm talking about right now. Let's get rid of all of that, okay? So if I have a triangle that looks something like this, and we'll say that this side over here is 7, and this side is 13, and this will be a right triangle. And I'm not saying it's a 30, 60, 90. It's not a 45, 45, 90. I don't know what it is. And we'll call this angle A, B, and C. Well, what if I gave you this and I wanted to know what the measure of angle A is? Well, the first thing you have to do is you have to set up something true you know about angle A. Now, look at where angle A is located. Angle A is over here. And what two sides in relationship to angle A do I have information about? Well, I've got the 7, which is opposite, and I've got the 13, which is hypotenuse. So when I think about what trig function deals with opposite and hypotenuse, well, that would be sine. So that means the statement I can write is that the sine of angle A is equal to opposite 7 over hypotenuse 13. And so what we're saying is that if you take the measure of the angle A and put it into the sine function, the output is 7/13. That's the ratio of the two sides. Well, just like I said, everything in math that you can do, you can undo. And so I can use what's called the inverse sine function. Now think about this. What would the inverse sine function do? Well, if the input of a regular trig function is the measure of an angle and the output's a ratio, then for an inverse function, the input is a ratio and the output is the measure of the angle. Now, it's on your calculators that we're going to use in a second, and I'm going to show you where, but right now I just want to show you the math of it. So I'm going to take the inverse sine of this side of the equation, and then I'm going to take the inverse sine of the other side of the equation. These two things cancel each other out, and I'm left with just angle A is equal to the inverse sine of 7 over 13. Now, if I'm going to do that, all I have to do is let's kind of get used to calculators for a second. Okay, so here's your calculator we're going to use, and let's talk about the key things that you need to know where these things are. Let's see if I can make this a little bit bigger so we can see it. Okay, the things you've got to know where they are. First of all, we got to know where this mode button is. Okay, we can see our trig function buttons, sine, cosine, and tangent. Look above them. You've got the inverse of sine, the inverse of cosine, the inverse of tangent. You use those by using the second button. Okay, the reason why I point out the mode button is because we have to use mode to be able to know what to do in terms of how we want these angles given to us. Okay, there's two different ways they could give them to us. They can give them to us in radians, okay, or they can give them to us in degrees. Now, we don't know what radians are yet in this class. We'll talk about them eventually, but we're not there yet. And so what you're going to do is you're going to press the mode button, and you're going to see this screen right here. Okay, you need the word degree to be highlighted and not radian. If radian's highlighted, you scroll down, click over using these buttons right here until you're on degree, and then you press enter, and then degree will be highlighted. Excuse me. To get out of this, you need to quit, which is second and then mode. Okay, so in review, when you pick up a calculator, the very first thing you got to do, man, you got to press that mode button. And you'll get to this screen right here, okay? You'll see all this. You always need to make sure degree is highlighted. Once you have degree highlighted, then you can quit out of there by hitting second and then mode. Okay? Now what I can do is I can actually plug this into the calculator. And so what I've done is I should be able to hit second. Remember, to use these inverse trig functions, I'm going to use that second button. Second, and then hit sine, and it'll show me this, just like how I have it written. It'll show me, like this inverse sine, and I plug in what I want to put in there, and to make sure you close the parentheses. I've done it, and I've taken a picture of it, and this is what it looks like. Okay, so this is what you should have on yours. Okay, notice I've got the inverse sine of 7/13, and when I hit enter, I get this angle right here, this 32.5789703, and this actually goes on forever. And so typically on a lot of these problems, we're going to talk about how we're going to round things, but for today, let's just go to the nearest whole degree, or maybe, let's see. Yeah, we'll go to the nearest whole degree for the angles. And for anything we're dealing with the sides, we'll go to the nearest tenth. So for this one, I'm going to say that A is about 33 degrees, 32.57, round up to about 33 degrees. I'm good with that. Okay? And so now think about what situation we had. All we had were two sides, and we were able to come up with the angle. A is about 33 degrees. Now, if A is 33 degrees over here, how big does B have to be? We got to remember that A and B have got to be complementary. And so then A would have to be 57 degrees. Now, if I wanted to figure out how big this side is, I could go back and I could use some of these trig functions with these angles, except these angles aren't the numbers I started with. I've rounded some things. So the best way to find this side right here would be use the Pythagorean theorem. And for today, and today only, when we use the Pythagorean theorem, you can go ahead and use the square root button and round it to the nearest tenth. So for this case, I would go 7 squared plus 13, or not plus 13, 7 squared plus whatever b squared is equals 13 squared. And 7 squared is 49, plus b squared is equal to 169. Subtract that, and you get b squared is equal to 120. So b is equal to the square root of 120, which is just underneath 11. And it's so close to 11 that I bet when we round it, it will actually go up to 11. Let's see. I get, 10.95. And so, I wrote 121, didn't I? So that is approximately 11.0. Okay. And so that's what you would get. Because we are being approximate for today only. All right, what we're going to do right now is we're going to practice this kind of problem over and over. That may have been a real fast shot at it, and you didn't see exactly all that happened. So we're going to do these over and over, okay? Let me do one more together with us. You should be writing this down, okay? So let's start with a triangle. Let's see here. We'll start with a triangle. We'll say it looks like this. Here's our right angle. Let's give these some sizes. We'll say that this thing right here is about 10. If that's 10, I think this is about 7. we could go ahead and use the Pythagorean theorem. We would figure out that this would have to be a square root of 149. I'm mostly concerned that we can do the trig of it. I think you guys should be able to do the Pythagorean theorem by now. And we'll call this A, B, and C. Now, here's the thing. Let's say, for instance, I didn't know the Pythagorean theorem. And so I'm going to take away the 7 for a second. And let's say I had no way of figuring that out. What trig functions could I still use to solve this? Okay. And so you think about, well, if I wanted to do A, well, now I'm dealing with adjacent and hypotenuse. So that would be cosine. Cosine of angle A is equal to the adjacent over the hypotenuse, right? Or you could think about it in the perspective of angle B. And you could say sine of angle B is equal to opposite, which would be 10, over hypotenuse, 149. So you could use sine or cosine depending on which angle you want to go after. Now, we can't use tangent because we don't have a situation where we have opposite and adjacent. But if we did use Pythagorean theorem and we figure out that this side was 7, well, then we could use tangent to figure out these angles as well. We could say the tangent of angle A is equal to opposite over adjacent, or the tangent of angle B is equal to opposite over adjacent. And we could do the sine of A. Okay, we could say that the sine of A is equal to 7 over the square root of 149, or we could say the cosine of B is equal to 7 over the square root of 149. We got all sorts of options. So all of these ways, we got 6 different ways to figure out these angles. This is really easy, okay? But so we're just going to go ahead and pick one. This makes no difference which one you're using. You will get the exact same values. And if you don't, you did something wrong, okay? So let's try this. Right now, just for the sake of fun, I'll use the 10 and 7, so that way I can just use tangent. And so I'll say the tangent of angle A is equal to opposite over adjacent. And if that's the case, then I can do the inverse tangent of both sides and say the inverse tangent of tangent A is equal to the inverse tangent of 7/10. The inverse tangent take care of each other, so I'd say that angle A is equal to the inverse tangent of 7/10. So that's when I grab my calculator and I hit second and then tangent, and I put 7 divided by 10, close the parentheses, and hit enter. And on my calculator, I get that A is then approximately, I get 34.9920202. And so I'm going to say, well, 34.99, yeah, that's about 35 degrees. Notice I'm using this approximate symbol right here. Okay, so if A is about 35 degrees, then B would have to be 55 degrees. And I'm able to figure out these angles that quickly. All right. Hopefully at this point, you guys feel ready. You could do one on your own, because that's what it's time for. Time to do one on your own. Okay, so here we go. Here's the triangle. We'll say it looks something like this. That's a pretty rough looking triangle, but we'll get over it. Okay, we'll call this A. We'll call this B. We'll call this C. All right, I'm going to give you some of the sides. I'm going to say that this side, I don't know, this side right here looks like it's about 7, and this side is 3. And here's what I want. I want to know what is the measure of angle A. I want to know what is the measure of angle B. And I want to know how long side C is. Okay? Use whatever functions you want to use. Do this however you want to do it. But in the end, I need you to do it. Okay? I'm going to give you you should be able to bang this out in definitely less than 5 minutes. Do your best. We can pause the video right here, and then I'll come back and finish it up. All right, let's take a look at it. Okay, if I'm going to do this before I even use the Pythagorean theorem, man, I'm just going to go ahead and say, well, I know that the tangent of angle A is equal to opposite over adjacent. So therefore, I know the inverse tangent of the tangent of angle A is equal to the inverse tangent of opposite over adjacent. These cancel each other out, and I get that A is equal to, grab my calculator, say second tangent, so I get that inverse tangent, 3 divided by 7, and you should get 23.198590. That's what I'm getting. I'm getting 23.1985 ... So we go, it's approximately 23 degrees. Angle A is approximately 23 degrees, okay? And so that can go up here. 23 degrees. Now, what's B's relationship with A? Well, they're complementary. So this would be about 67 degrees. And then how do we figure out C, side C? That's this side right here. Well, that we can just use the Pythagorean theorem. And we say that 3 squared, which is 9, plus 7 squared, which is 49, is equal to C squared. So therefore, C squared is equal to 58. C is equal to the square root of 58. And if we plug that into the calculator, we would get about 7.6. Okay, about 7.6. I know I have equal signs right here and here and here. I apologize. Those are clearly kind of inappropriate because I would be really saying that this is approximate. Okay, all right. Hey, let's try another. See if you guys, the more you practice these, the better you get at them. It's just they start to go quicker and quicker. All right, so let's try another one. Let me draw the triangle. Oof, that's a little bit too rough. Okay, so here's my triangle. Here's my right angle. Call it A, B, C. I'm going to say that this side out here is 18. And let's see, if that's 18, this side right here is probably about 10. Okay, I want you to find the measure of angle A. I want you to find the measure of angle B. And I want you to find the length of side A. Okay, so go for it. We can pause the video right here. 5 minutes later or less, we'll come back and we'll finish this. Okay, hopefully you're ready and we can do this. So what I'm going to do, I just, we keep starting with A. There's no reason you can't start with B. And so for this circumstance, I will. I'll go ahead and say, well, I know that the sine of angle B is equal to opposite over adjacent. Now, maybe you all chose to do the cosine of angle A. That's fine. It'll give you the exact same answers. I just thought, well, we've been doing A. Let's swap it up and do B. So that would mean that I know that the inverse sine of the sine of B is equal to the inverse sine of 10 over 18. These cancel each other out. I'm left with the angle B is equal to the inverse sine of 10 over 18. Now, can I reduce that and say that that's 5/9? Absolutely. Okay, don't have to. You get the same answer either way, but you can. And it's always a good idea to reduce. So that would give me that B is equal to 33.7489888. So we go, well, B is approximately 34 degrees. So if B is approximately 34 degrees, then A is approximately 56 degrees. And then I can use the Pythagorean theorem to figure out little a. And so I'd know that, let's see, 18 squared is what, 324. So we know that 10 squared, which is 100. So 100 plus a squared is equal to 324. So a squared is equal to the square, or is equal to 224. So a is equal to the square root of 224. And so I go 224, which is about 14.966. And so, of course, yeah, because that's almost 225. So it's about 15. All right. You should be able to do these this easily. In my other trig class, we actually started doing races where we were seeing who could get everything done the right way. All right. We should be taking no more than just a couple minutes to bang this out. You can see how simple they are. All right. So what we're going to do is we're going to do one or two more, and then we're going to kind of practice this for real. If we are down to having less than 15 minutes left, then we should stop. But I think you probably have a little bit more time than that in class. Once we're down to about 10 or 15 minutes, we'll stop this in case, even if I have more practice to give, we can go ahead and stop the video right there. Okay, let's do another one. Okay. Ooh, that last line was kind of rough. Okay, so here's my right triangle. We'll say, I mean, obviously it looks pretty close to a 30, 60, 90, but I'm going to say it's not. So we're going to say that this is 10. And this side right here is just a little bit bigger. We'll say 13. Okay. This is A, B, C. Ready, set, go. Trying to find angle A, angle B, and side A. You can pause the video right here, and then we'll go through it in just a second. Okay, let's do this because this is quick and easy. Okay, I'm going to start by saying, well, I know that the cosine of angle A is equal to adjacent over hypotenuse. So therefore, we know that the inverse of the cosine of angle A is equal to the inverse of 10 over 13. These cancel, therefore angle A is equal to the inverse cosine of 10 over 13. Grab my calculator. Inverse cosine, so that's second cosine, 10 divided by 13, close the parentheses, and we get 30 nev 39.715 something. So we go that A is about, not 39. If we're going to round to the nearest decimal, or I'm sorry, nearest whole degree, it'd be about 40 degrees. So if A is 40 degrees, B is 50 degrees. Okay? We can find the side A by saying, well, we know that 10 squared, which is 100, plus whatever A squared is equal to 13 squared, which is 169. Subtract that, we get A squared is equal to 69. So therefore, A is equal to the square root of 69. We plug that into a calculator, and we say, well, square root of 69, that's about 8.3. Okay? So A is about 8.3. You guys should be this fast, okay? Let's try it again. Again, once we get down to about 15 minutes left, we can stop the video, but I just want to keep practicing these for just a little bit longer, okay? Here we go. We'll look at this one. We'll say this side right here is 9, making this side 6, okay? And I'll say this is A. This is B, here's C. So I want the measure of angle A, I want the measure of angle B, and I want the length of C. Ready, set, go. We can pause the video right here. Okay, for this one, you can use tangent of either angle. It doesn't matter. So for the sake of being different, I'll say tangent B is opposite over adjacent, which is the same thing as that reduces down to 3/2. Not that doesn't make any difference, but opposite over adjacent. So then I know the inverse of tangent of angle B is going to be equal to the inverse tangent of 3/2. These cancel out, and B is equal to the inverse tangent of 3/2. So therefore, B is, so grab my calculator, inverse tangent of 3 divided by 2, close the parentheses, and I get 56.3099 something. So we'd say B is approximately 56 degrees. So if B is 56 degrees, then we know that A is 34 degrees. We can use the Pythagorean theorem and say 6 squared plus 9 squared is going to give me that hypotenuse squared. So that's 36 plus 81. 36 and 81 is what, 117? Okay. Yep, 117 is equal to C squared, so therefore C is equal to the square root of 117. And I got all the information. Angle B, angle A, hypotenuse. Okay, if you have some time left right now, I'd really like you to practice just a couple out of the book. Once we get to having 15 minutes left in class, and we can be done with that practicing. But otherwise, we can go to the book, and we can go to page, let's see, what page am I on? Yeah, there we go. You'd go to page 76. Ooh, that's bad. You can go to page 76 and try 15, 17, and 21. 15, 17, and 21. They give you all the information about the triangle, but they do not draw it for you. All the answers of these three are in the back of the book, and you can check your answers. All right? Once you guys get to the point where you feel pretty confident about this, and or we only have 15 minutes left, then we're going to try this other worksheet that I have for you. Okay? All right, you guys have a great day.